Hello and welcome to the class. So today's topic is differentiation and it is for syllabus for the class 12 is level and basically differentiation is used to find the like gradient, maxima, minima, normals, tangents and all. So in today's topic we will cover the questions and based on that we will discuss the formulas. So first question, if you see, this is find the dy by dx, or sometimes we write about the f dash of x. So find dy by dx, and the question is sine x square plus 5. So for this we know, for if I write d by dx of differentiation of sine x, then the formula will be cos x. And if I write for differentiation of x raised to power n, then that will be n x raised to power n minus 1. Similarly, differentiation of any constant value will be 0. So using these formulas we will solve this question, differentiation of sine x square plus 5. And this is basically the function of function. This is sine is one function and inside the sine there is another function x square plus 5. So how we can do this question, like if I write sine and this is what x square plus 5, so differentiation of sine x square upon 5. So first of all find the differentiation of sine, which is cos, so we can write it cos and x square 5, x square plus 5. Now differentiation of this function x square plus 5, so cos x square plus 5. Now derivative of x square, so we can write here 2 x raised to power 2 minus 1 plus derivative of constant will be 0. So we can write here cos x square plus 5 and 2 x raised to power 1. So first of all we'll write value of 2x, then cos x square plus 5. So this is how we can find the differentiation of function of function. One more rule we can write here, differentiation of u plus v is equals to differentiation of u plus differentiation of v. So similarly we can write also, if you want to write if there is any other question like the cos x, so we can write the differentiation of cos x is minus of sin x. So these are the formulas. So next question, we'll move to the next question and we'll see what kind of questions. So now question is differentiation of cos of sin x. Again this is function of function we can see here, and we already discussed like differentiation of cos is minus of sin x. So first of all we'll write here differentiation of cos of sin x. So this is again function of function, we'll write here minus, derivative of cos x is minus, and function inside function is sin x. Now again derivative of sin x inside function, so we can write here minus of sin x, and then derivative of sin x is cos x. So we'll write this first, cos x minus cos x into sin of sin x. So this is how we do derivative of function of function. Now like if you want, if you are comfortable, you can also write like u is equals to sin x, like the inside function, and then du by dx, derivative of u is equals to cos x. Okay, now what we need to find out, now the function will be cos u. So what we will write here, derivative of cos u, will write here minus of sin u and then du by dx. Now we can write here minus of sin x, sin, and what is value of u, so you already wrote like this, sin x, and then the derivative of du by dx from 1 we can write here cos x. So again you can see you will get the same answer. So either way will be the answer. Either you can directly do it or you can use u, or you can take any variable in the function you can define, and then you can do it. Next question is like sec of 10x. So we know derivative of sec x is equals to sec x into tan x, and derivative of tan x is equals to sec square x. So using these two formula we will solve this one. So first of all, what we will do, again, if you want you can use variable, define the variable, or you can do directly. So first of all, we'll write here derivative of sec tan x. So we know the derivative of sec x is sec x into tan x. So we'll write here sec, and see this is x. So we'll write here sec x into tan of tan x. Now we need to differentiate the internal function, which is tan x. So we'll write like this. Now derivative of tan x we know sec square x. So we'll write here sec square x first, this one, and then we'll write this one. So we'll write here sec of tan x into tan of tan x. So that is our final answer. So in case like if you got confused with this, what you can do is just define tan x is equals to u, and then find du by dx, and then use the function like sec u, like differentiate the sec u, and then you can write du by dx. So either way is correct, whatever like the approach you can do it, and you can solve the questions. Next question is find the dy by dx of 2 root under cot x square. So first of all, we'll discuss what formula we can implement here first. So derivative of root x. So derivative, either you can write directly to root x, or you can just use the algebraic one like x raised to power n, which is n into x raised to power n minus 1. So here we can write like x raised to power half, so we can write it half x raised to power half minus 1, and then we can write half into x raised to power minus half. So we can use indices, and we can write 1 upon 2 root x. So this is one the formula of dy dx of root x. Another formula we will use like derivative of Cortex. So derivative of Cortex is like minus of cosec square x. So these formula, using these two formula, will solve this question. So first of all, this is what 2, so we're going to leave 2 constant. So how we can write here like 2 root under cot x square. So first of all, we'll leave constant as it is because this is in multiplication. Then derivative of root x. So what is derivative of root x? So we'll write here 2 root x. So instead of this, we'll write here 2 root cot x square. And now whatever the function inside the root, we will differentiate again, so which is cot x square. Now 2 and 2 got cancelled, so next step what we can write, root under cot x square. Now derivative of cot x is, we know, minus cosec square x square, and then again there is a derivative of x square because the inside function of cot is x square. So what the final answer we can write, minus of cosec square x square upon root under cot x square into derivative of x square is 2x. So final answer we can write first this term minus 2x, and then cosec square x square, if you want you can take bracket, upon root under cot x square. So this is our final answer for the question. Now we'll move to the next question. So see, using this we are doing those formulas as well as the question. Now this question is based upon sine and cos. We already know what is the derivative of sine. The derivative of sine is cos x, and the cos x derivative of cos x is minus sine x. Now this is what something u upon v. So what we can do, first we'll write here derivative of u into v. So what we can write, u derivative of v plus leave v, then derivative of u. Now we can use u upon v, which is actual requirement. So in this case we'll write here derivative of v square, then leave v, differentiate u, minus leave u, derivative of v. So this formula we are going to use here. So first of all, what we will write here, differentiation of this is like u and this is v, so derivative of, so we'll write first cos cx plus d whole square, like cos square cx plus d, right? Now we'll leave cos, so cos cx plus d, and then derivative of sine ax plus b. So first part is done. Now there is space issue, so what we'll do, I will write here now minus u, leave u, so u is sine ax plus b, and then derivative of cos cx plus d. Okay, so next step what we can write here, so cos square cx plus d, and then cos cx plus d. Now what is derivative of sin x? Cos x, right? So we can write here cos ax plus b, and then this is function of function. What is derivative of ax? So derivative of ax is a, because derivative of x is 1 and b is constant, so 0, minus. Similarly we can write sine ax plus b into derivative of cos is minus, so we'll take bracket, we'll write minus sine cx plus d, and then derivative of cx is c, bracket close. So if you want, you can leave the next step. What we can write here, a, and then cos ax plus b into cos cx plus d, and then minus minus plus, this minus and this minus becomes plus. We can write here c first constant, then sine of ax plus b into sine of cx plus d upon cos square cx plus d. So this is how we can do the division things. If there is multiplication, then we can use the multiplication formula. If there is division, then we can use the division one. So moving to the next question, and we'll see like what kind of question it's. So this is, now y is not directly given. This is like 2x plus 3y is equals to sin x, and they ask us to find dy by dx. So how we can, so we'll write here differentiate both the side with respect to x. So we are differentiating both the side with respect to 2 derivative of x with respect to x, derivative of y with respect to x is equals to derivative of sine x. So how we can find out derivative of x is 1. We can write here dy by dx is equals to derivative of sine x, we already discussed, is cos x. So 3 dy by dx is equals to what we can write here, cos x minus 2, and dy by dx is equals to cos x minus 2 upon 3. Sometimes they can give you some like values, like at what value, like x is, if x is equals to 30 degree or 45 degree, then what will be the dy by dx, or the gradient of this line or something. So you can use the same thing and find out the value, like you can substitute the values and then you can find the value of dy by dx. Now moving to this one, so this is what inverse. So there are formulas for inverse also, so I'm not going into that, we will cover into the another video. But how we can solve this like sine inverse theta, like we can, if I wanted to write for the sine inverse x, I can write here root under, okay. But here what we can do, we will do something else to solve this one. So first of all, what we will do, uh, we'll try to substitute, because see, this is like big value. If I'm going to use this one, we can do using this formula method also, but I'm just trying to give you another method like which will be useful for you. So just consider like x is equals to values, like if we consider the values, that will be helpful. So just try to use any value and then see whether it works or not. So I'm going to take the value is like x is equals to tan theta. So what value we have actually inside the sine inverse? 1 plus x, 2x upon 1 plus x square. So what we can write here actually, 2 tan theta upon 1 plus tan theta. So 2 tan theta, and we know 1 plus tan theta is equals to, there is formula 1 plus tan square theta is equals to sec square theta. Now can we convert this tan theta into sine theta upon cos theta, and this will be like 1 upon cos theta, sorry, cos square theta for the sec square theta. We can cancel it and we can write here 2 sine theta into cos theta. So basically we can write here sine of 2 theta. So this value is equals to basically sine of 2 theta. So if you substitute the value, then we can get this value in terms of sine theta. So why I did this, because sine and sine inverse can get cancelled, and then we'll have easy value for the substitution. So one more formula I'm going to write here, derivative of tan inverse x, which is 1 upon 1 plus x square. So these two formulas can be useful, either you can use directly or the substitution method which I just now explained you. So here I use the substitution method, and the 2x upon 1 plus x square, after substituting the value of tan theta, we got sine of 2 theta. So now we can write the question is equals to sine inverse of sine of 2 theta. So we can write here 2 theta, because sine and sine inverse get cancelled. So we can write 2 theta. What is value of theta? So this tan we can move it here, and we can write theta is equals to tan inverse of x. So we can write here tan inverse of x. So now we have question, like we simplified the question, y is equals to 2 tan inverse of x. So now dy by dx, we have formula 2 is constant, and tan inverse x we can write here 1 upon 1 plus x square. So this is our final answer. We can write 2 upon 1 plus x square. So this is easy way. If you want, you can use directly formula sine inverse x, try. And if you get like any issues, if you stuck somewhere, then you can just leave your comment in the comment box, and then I will try to help you in the next video. Now moving to the next question, like again there is sec inverse 1 upon 2x square minus 1. So again I'm trying to, you can use the formula, but I'm just going to try use one formula for this one. So like trigonometric things. So what I will do here, I will just try to put here x is equals to cos theta. Just check like, so in your mind, like how I can substitute this cos theta, why not tan theta or any other value. So I will cover these things in the trigonometric chapter, where we can see like what values we need to. So actually what is our requirement inside? If there is a sec inverse outside, then we need sec square inside also. So how we can convert into the sec square? So based on that, like using this substitution, we can do it. So how we can do it, just try to check this, what is the value of 2x square. So can we write like 2 cos square theta minus 1, and cos square theta, can we write like this? See, this is one formula directly I can write here. This is cos square 2 cos square theta minus 1 is equals to cos of 2 theta. Or I can write here like sine square theta. I will substitute here the value of 1 is equals to sine square theta plus cos square theta, and 2 cos square theta minus of sine square theta minus of cos square theta. Again I can write here cos square theta minus of sine square theta. Again we can say this is what cos 2 theta. So either way you can use this cos 2 theta or this, anything is fine. So what I'm going to do, if I'm substituting this one, so I will get 1 upon cos 2 theta. And now see how this is simple now. 1 upon cos is sec, so we can write here sec inverse 1 upon cos is sec 2 theta. Now sec inverse got cancelled. I can write here 2 theta. Now 2 theta, what is value of theta? If you see here, this one. So I can write here cos inverse theta is equals to x, right? So can I use this? Yes. So I will use 2 cos inverse of, sorry, cos inverse x is equals to theta, sorry. So cos inverse x. Now I can easily differentiate it and I can write a derivative of cos inverse is equals to minus 1 upon 1 minus x square. So I can write here 1 minus of 1x square, sorry. So now final answer will be like this. So this is like if we substitute the values like the trigonometric, if trigonometry is strong, then we can easily differentiate and integrate the inverse function. So we'll have a discussion on the trigonometric chapter once I will start. Meanwhile, if we'll have like any issues while like for conversion, then you can reach out to me via comment. So moving to the next question. Now this is what again ex upon sin x. So we already discussed about this, like derivative of ex is equals to, we know ex, derivative of sin x is cos x, and we discussed sin x is cos x, and with what we discussed derivative of u upon v, which is, yes, which is v square. Then you have to leave v, derivative of v, u minus leave u, and then derivative of v, right? So you have to implement the same one. So can I write directly find dy by dx was the question. Let me write it for you. Sometimes they can ask like find f dash of x, if it is f of x, anything they can ask. So what I can do, I can write here sine square x, I can leave sine x and try to differentiate e raised to power x, minus e raised to power x I can leave, and then I will differentiate sine x. So sine x, derivative of e raised to power x is same, e raised to power x, derivative of sine x is cos x upon sine square x. If you want, you can take common. I can write here like sine x minus, sorry for the bad handwriting, upon sine square x. One more thing, if derivative of e raised to power ax, what I can write, a into e raised to power ax. How we can write? See, derivative of exponential function is same, and what derivative of ax is a, so that's why this is e raised to power ax. Okay, so this is like we covered the exponential function also. Now this, so raised to function raised to power function, then how we can differentiate? For such question, if they ask us to find dy by dx, consider this one. Like first of all, I will write here derivative of log x, logarithmic function is 1 upon x. So for such question, consider y is equals to log x raised to power cos x. Now for such question, when there is a function raised to power function, you have to take a log. So taking log on both sides. So when we take log on both sides, so what we can write here, log y is equals to log of log x, like this. So we know if log x raised to power m, so we can write here m log x, right? M into log x. Similarly, we can write here cos x into log of log x. So there is u into v, as well as there is a function of function. So now what we need to differentiate with respect to x. So what we can write here, log y 1 upon y dy by dx. Now u into v, so we already discussed u into v. If there is u into v, you have to leave u, differentiate v. Anything is fine, like you can leave v also, then leave v and then differentiate u. Similar pattern we'll use here also. We'll leave cos x, derivative of log is 1 upon log x. Why? Because derivative log of x, that's why 1 upon x, into again derivative of this log x, we can write here 1 upon x, plus now we are going to leave log of x, and we'll write derivative of cos is minus sine x. Now how we can find dy by dx? Just we need to simply shift this y and we can write here cos, just multiply and write here x log of x plus, sorry, plus and minus is minus, so we can write here minus log of x. Simply put the value at the end of the question, like y, what is value of y? Log x in raised to power cos x, and that will be your answer. So due to the space constant, I'm not writing, but you can write. If in case any issues, then you can reach out to me. So like for the logarithmic function or the function raised to power function, how we can differentiate? So taking log on both sides, and then you have to differentiate with respect to y, sorry, with respect to x, and then you can use the formula, whatever the formula is required. So for the today's final, like how we can find the gradient for the curve, is like the question is find the gradient of the curve is like 2x minus 3 is to power 5 at the point 2 comma 1, and this is like using the differentiation. So we'll use simple differentiation, dy by dx will find out. Gradient is dy by dx, so we can write using, we know derivative of x raised to power n is equals to n x raised to power n minus 1. So 5, 2x minus 1, 5 minus 1. Now function of function, derivative of 2x is 2, derivative of x is 1, minus derivative of 3 is constant, so it is what, 0. So 2 minus 1 is 2, 2 into 5 is 10. So we can write here 10 into 2x minus 1 raised to power 4. So this is dy by dx, or the gradient. Now gradient, they are asking us to find out gradient at 2 comma 1. So that means this is x and this is y. The value of x, what we can write here, 2 into 2 minus 1 raised to power 4. So 4 minus 1, 3, 3 raised to power 4. So 3 raised to power 4, 3 into 3 into 3. So 81. So 810. So this is how we can find the gradient. So I will, in the next video, I will discuss more complicated question. For now, thank you so much for watching this. If you like, share and subscribe. Thank you.